Guys, we're about to get into a very different video. Now, it ties in what we've been watching, but we're going to look at it from a slightly different angle and look at where we're going from this. What we've been watching, guys, is the, of course, Lake Mead, Lake Powell, all of that, but now we're also seeing that Utah and the big forest fires there. Now they've jumped into Colorado and they are crossing the peaks, guys. Normally you would have melting snow. I mentioned this before. That would dampen all that down. Again, the alpine cooling effect. But without that, guys, it's burning over the tops. And what that does is kill the seeds. They have no moisture left to sprout for the next year, things like that. It really changes the entire environment. That's why this is called the Age of Ash. And going back to 1960, guys, they started making a definition of the ages. You know, we're in the Halcyon. You go back, you got these different periods. But again, we're in the Halcyon period now. So we're going to look at some of the history here. We're going to look at some of the details, the data involved in this, and the actual changing of ages. We're in the Halcyon period. That's basically coming out of the Ice Age. And you're seeing two images here. One with the alpine cooling of the Rockies and one without it on the left side. And guys, it goes much deeper than this. And I don't want you to go anywhere because we're going to go into some very good details. I think you will get a lot out of it. And it will, again, open your eyes and minds to different events that may have a difference in the way you plan your future even. Let's get into it. Now, this map is key to what I'm talking about. You go back into the 1800s, and there was a fella that was an explorer. He did a lot of things. His name was John Wesley Harding. And he came up with this map called the 100th meridian that you're looking at now. In those days, this 100th meridian indicated where we went from desert in the west to the grasslands and the moisture to the right. Again, going back to John Wesley Harding. But what they've seen now is that point, the 100th meridian has not changed, but that point is changed to the 98th meridian. Look right here. And that 100th meridian is famous. Going back to songs, there's still street signs up about it as you go through the west. You got one up in Nebraska and just all over. And it really is an intersection. You got railroads, old railroads that intersected in the Nebraska area. You got the Continental Divide. A lot of things are involved. But what is changing again is this 2 degrees difference in where the desert aridification is moving. And what are we seeing, guys? The depletion of one of the largest aquifers in North America that feed all of this area. Now, it's interesting that when John Wesley Harding did this, guys, if you trace the center line, and I've been through Texas many, many times. I was born in Austin, but we go through there, driving through there and then through Roswell and through the mountains of New Mexico and Arizona to see our kids and grandkids in Phoenix, right? So I've been there, and you can see the changes in this aridification factor. And Texas is a perfect example, guys, because if you look at the original, well, it's still the 100th meridian, but it's no longer that aridification border. But it goes right up the state line of Texas where it meets Oklahoma. Exactly. That was drawn on the 100th meridian. Just whether it matters or not, but I wanted to point it out. If you can put it on a map, you can find it very quickly like that. But it's moving east. Just like the fires are coming out of Utah and moving east into Colorado. I know it's happened before, guys, but it's getting to a point now to where we're moving out of the entire age for the planet, and we are living to see it. Now, take a quick look at this black and white from 1879, guys. This is a train stop. Now, I don't know if they had just erected this on the 100th meridian or not. It's, I think it says 247 miles from Omaha, Nebraska here. But anyway, they were quite proud of the the railroad was. And again, it was the westward expansion that we're seeing starting back then. It finally ended up getting into California, bouncing back into Nevada, and all of it had a lot to do initially, I think, with the gold rush. Not all of it. We saw some migration, guys, back during the summer or the year without a summer, where people migrated from the northeast westward just to be able to plant crops and eat. Now, let's look at this particular graph. We had been in the Cenozoic period here, guys. It was moist. They're saying that we are in the Holocene period, again, coming out of the Quaternary period. In other words, like sub-periods, not quite the entire, say, Ice Age or whatever period you want to look at, the dinosaur ages or whatever. But the Anthropocene, guys, is since 1960, when it became a term, has been moving very quickly. And what that means is that now the Earth is not dealing with natural changes like during the Cenozoic or the Quaternary. It's dealing with forced man-made changes, thus the name Anthropocene. And we are seeing it as we speak. We are alive to see a change in the ages. But what does it mean? It means is just as that line moved from the 100th meridian to the 98th meridian, as you're planning, maybe you don't want to be in a dry desert without AC. You might have to look at the drought situations, and we're going to get deeper into that, looking into Colorado and Utah, but you may want to look a little further east or a little further north than where maybe you plan, because you saw that 2-degree change in the actual line between the desert and the forest. Now, when you look at the carbon taxes and some of the hype around global warming and all of that, and some of the pushback, if you don't go along with the exact mainstream narrative, we are seeing it here. They're saying that the Anthropocene is a term that has been used to refer to the period of time which humanity has become a planetary force of change. Not nature, man. It appears in scientific and social discourse, especially with respect to the accelerating geophysical and biochemical changes that characterize the 20th and 21st centuries on Earth. Originally a proposal for a new geological epoch following the Holocene. It was rejected 2 years ago, guys, as we saw the peak of a lot of scientific narrative change, such as the deserts have plenty of water. Don't worry about that. Listen to YouTubers. Plenty of water, plenty of electricity. It's going to snow tomorrow. You understand what I'm saying? But anyway, the International Commission there, guys, and the International Union of Geological Sciences are the one that said, no, this is not happening at this time. They're sadly mistaken. They're 2 years, this is 2 years old when they rejected it after going back, 64 years and accepting it as a possibility. But now, kind of like Al Gore, things are not what they seem. And again, look at the money involved in the housing, the developments, the industries in the desert Southwest, and you'll see why commissions can change their mind very quickly, especially when their ledgers get a little bit low. Now, this term, though, is still being used in what they're calling sophisticated research, not the dumbed-down version. It has research related to Earth's water and salt, geology, geomorphology, landscape, limnology, hydrology, ecosystems, and climate. Do you understand? Not the deniers, but the people that have eyes that are open. The effects of human activities on Earth can be seen, for example, in regards to biodiversity loss and climate change. Various start dates for the Anthropocene have been proposed, ranging from the beginning of the Neolithic Revolution 12,000 to 15,000 years ago at the end of the Younger Dryas to as recently as the 1960s. The biologist Eugene F. Stormer is credited with first coining and using the term Anthropocene informally in the 1980s. And Paul J. Crutzen, guys, he reinvented and popularized the term. These people are visionaries. They see the data. They don't look back and say, how can we stop it? They realize it's unstoppable. Mother Nature has taken back. And this time, since that 100th line was put in there, on that particular marker, guys, things are changing rapidly. Look at it, man. Again, it's the effect of man, this particular age we're going into. And they have classified it, they have realized it, and they are studying it just the way you and I are right now. Again, they're saying we're coming out of the Quaternary. And on that chart again, that's what we saw. It says the AWG, or the Anthropocene Working Group, or they're in a subcommission. Now let's go back to this chart just a moment. Again, coming out of the Cenozoic, and what they're saying is we're not into the Anthropocene. These are the well-paid scientists. These aren't the real researchers. It's obvious. Anyway, they're saying we're still in the Quaternary, not the Anthropocene yet, which is part of the Holocene. But let's look at both the Cenozoic and the Quaternary. We'll decide for ourselves. Now, this era, which means new life, is Earth's current geological area. Now, they're saying, the mainstream scientists, that we're still in the Cenozoic period, but well, there's a time lapse sometimes between the eras where they overlap. You'll see the changes, and you'll see the effects of it. Sometimes it changes much quicker, and that's what we've been seeing for the last few years in the desert Southwest. It says the Cenozoic era, also known by its different names, but it means new life. It's Earth's current geological era, representing the last 66 million years of Earth's history. It is characterized by the dominance of mammals, insects, birds, and angiosperms, guys, which are flowering plants. It is the latest of three geological eras of the Phanerozoic eon, preceded by the Mesozoic and the Paleozoic. Now let's look at the Cenozoic just for a moment. And the pictures on the right, guys, are from St. Andrea, Salento, Italy. It's rock deposits from the Cenozoic area. Check that out. See the different deposit levels. Guys, you know how many times the Earth has changed in 66 million years. Think about it. Anyway, it was characterized by the dominance of mammals, insects, birds, and angiosperms, which are flowering plants. It's the latest of three geological eras of the Phanerozoic, the Mesozoic, and the Paleozoic. But guys, before the era, the one that ended just before this one, it had a rough ending. It happened very fast. It wiped out the non-avian dinosaurs. They became extinct in an event attributed by most experts to the impact of a large asteroid or other celestial body. Again, this is not a man-made Anthropocene event. This was basically, I guess you would call it a solar system event or a galaxy event, natural occurrence. Right now is the first time that it's ever been classified as a man-induced era. And just to put it in perspective quickly, the Cenozoic is divided into three periods: the Paleogen, Neogen, and the Quaternary. They're saying we're still in the Quaternary. We're in a very fast change of an overlap between the Quaternary and this Anthropocene. Now, we're going to look at a couple of different fires. This is Cottonwood we've been looking at in Utah, but now it's jumped over and crossing some 14,000-foot peaks in Colorado that would normally be snow-covered. And guys, when snow comes back again, I've said this, if you don't have that alpine tree cover, any snow that hits is going to melt and run off very quickly. Again, the seeds for the next generation after a forest fire will not sprout. Here is, again, this is the Cottonwood fire. It is at 93,000 acres. It's about another 1,000 acres or 1,200 acres from yesterday. And what, again, I want to point out is it's crept further into these very high mountains. See this? Breaching all the tops. That is where the snow was cooled. That's where it was shaded. That's where the forest resprouted. It's reached these points. That's not a usual thing. Now, let's go over to something closer to what we're looking at about moving that 100th meridian line. Let's go over into Colorado. Now, this is called the Gold Mountain Fire, and it's done the same thing. The reason I'm coming here, it's zero containment, but it's a new fire, but it's 7,103 acres right now. And it's done the same thing. Again, we're moving to the east, just like the 100th meridian has moved to is now the 98th meridian. Let's put it that way. But as we zoom in on this, again, here's Gold Mountain fire, and very hilly, just Colorado, right? Mountains and stuff like that. But it's breaching them. You see where it would normally be snow, much cooler temperatures, everything's changing. And in other words, Mother Nature is not just taking back the desert Southwest, it is now encroaching further east. Listen to me. Again, that's why the Midwest farmers are in trouble, and it's reclaiming it. Why? Why is it reclaiming the desert Southwest, guys? Man has pulled all the water out. Now look at the Ogallala aquifers. Over in the area now where the 98 parallel is looking at, guys, I mean, in that area, that's been drained. Nature knows how far it has to spread to shed what's happening. They have to pull, I guess, the data centers off, the big heavy farmers from drilling down too deep because they've depleted it. In other words, for this area to even try to rebound, it has to stop what is happening. Now, let's look at some of these effects. It says the destruction of alpine vegetation on burnt mountaintops will accelerate future snow melt again. Though it will not significantly change the amount of the snow that falls, but because the canopy, the alpine shrubs, and soils have been stripped away, the high-altitude winter snowpack will face drastic shifts. Of course, you're in some of the worst areas that we're looking at Gold Mountain fire for avalanches already. But the faster spring melt, without a tree canopy or ridge vegetation to provide shade, the snowpack will be directly exposed to intense solar radiation. The sun will melt in the snow weeks earlier than normal in the spring. The albedo effect. Wind will block or will blow black soot, ash, and charred debris onto the pristine white snow, if it gets any. This darkens the snow surface. Hot attracts heat, white reflects it, right? It's causing it to absorb heat instead of reflecting it, which further speeds up melting. In other words, nature's reclaiming this area, guys. It's not allowing the seeds to reproduce, for the mountains to come back, for the alpine cooling to come back. Under these conditions, it has completely shrugged. Now, guys, it's going to affect a lot of other things. You've got dams throughout that area, up and down these rivers and these mountains, leading all the way back over into the Colorado River Basin that Meade and Powell and all on. But all of these smaller dams in between, guys, when they have these big fires and then they have a rain, runoff and mudslides and things like that, sides of hills collapsing, it quickly clogs the rivers and the reservoirs as it's pushed downstream, and makes them hold a lot less water and makes it very hard for them to clean it out to get good water flow. It can stop up the dams and cause a lot of damage, but it's dam after dam after dam, including places like Lake Powell, that has seen this happen. But now it's moving into Colorado. This vegetation acts as a natural anchor for the winter snowpack. Bare, charred mountaintops provide a smooth surface, vastly increasing the risk of slab avalanches on steep slopes during heavy winter storms. And so this ash and soot that goes in there, guys, you can't drink it. It's very hard to filter, very expensive to filter it. So Mother Nature's cutting off more than just what we're seeing in the desert Southwest. It's moving east. And this information documents it, guys. And this is about the severe impacts on what they call the ORAY local watershed, or the ORAY. You guys know about it. I'm probably not pronouncing it right. I've only been to Colorado one time, and I can't remember the name of the road that left from Golden and wound north and come out at Boulder, but went through there and on the creek. We climbed one of these tall alpine mountains, and it was beautiful. Beautiful trees. Along the top of the mountain when we got there, it was flat with flowers, big chunks of white granite and marble. Beautiful place. It's changing. But the loss of alpine vegetation creates immediate and long-term threats to the local water supply. Water contamination without plants and roots to filter rainwater. This goes all the way to drinking water. That's the problem with the whole thing. Without plants and roots to filter rainwater, future storms and spring melts will wash massive amounts of black ash, charred debris, and heavy metals directly into the Uncompahgre River. Guys, someone correct that. I'm not familiar with it. Anyway, and local creeks. This dramatically increases water cloudiness, making it much harder and more expensive for local water treatment plants to purify your drinking water. The flash flooding, these intense wildfire heat bakes the alpine soil, creating a hydrophobic water repellent layer. Instead of soaking into the ground, rainwater and melting snow will sheet off the mountaintops instantly, creating rapid, dangerous flash floods in the valleys below. And as the higher we see these fires go up into the mountains, the more these effects change. Guys, mudslides and debris flows, tree roots act as the structural anchor holding mountain slopes together. When these roots burned away, heavy rainfall can easily trigger massive mudslides, sending tons of rock, mud, and debris crashing down into water infrastructure and roadways. It's all about water, and of course, transportation is important, but that's how this battle is being won by nature and lost by man. Water. And they are talking about now, you guys, there on US 550, including Red Mountain Pass, it's a heightened winter avalanche risk. It's already one of the most avalanche-prone highways in North America. The Gold Mountain fire that we're looking at will make winter travel much more dangerous. You're losing the high timber anchors, all of that vegetation, everything, and it's going to create what they're calling new avalanche paths. Slopes that were previously considered safe because of heavy forest cover, now think about this, are now completely barren. They will create brand new, unpredictable avalanche paths that can slide down directly onto the highway without warning. I don't think they're going to have as much snow to worry about in an avalanche. It may be a debris mud avalanche, but we'll see. But if it does happen, or even if it's heavy, heavy rains, we will see the same effect. Again, affecting the highways, any power lines, and the waterways. Guys, and just a quick look through the dams downstream from this Colorado fire. And just a few miles north of Ouray that we're looking at in the fire zone, the very first major dam is Ridgway, at the Ridgway Reservoir in Montrose, Colorado, operated by Tri-County Water. It manages critical municipal and agricultural water supplies for the Uncompahgre Valley. It will face immediate challenges with high water turbidity. Again, that is what you have to filter out. Ash accumulation and potential debris choking the intake valves. Mother Nature, when she comes into town, she leaves no stone unturned in her retaking. Then what happens, guys? After passing through the town of Delta, the Uncompahgre River joins the Gunnison River, while the massive Wayne N. Aspinall unit dams called Blue Mesa, Morrow Point, and Crystal sit upstream of the confluence of the main stem of the Gunnison. Any water diverted into the valley via the Gunnison Tunnel for irrigation will be mixing with the wildfire-polluted Uncompahgre water. They're already having problems because of agricultural runoff from the very top of the mountains to Mexico. But once the Gunnison River flows into the Colorado River at Grand Junction, the wildfire's downstream impacts hits the massive infrastructure of the greater Southwest. Right down to one of the main ones we watched, the Glen Canyon Dam. This is in the bridge you're looking at in Page, Arizona. Located on the Utah-Arizona border, this is the first mega dam on the Colorado River main stem to receive water from the Gunnison Basin. That's where the fires are. It is responsible for upper basin water delivery. It will ultimately absorb the fine ash particles and dissolved heavy metals, contributing to long-term siltation and reservoir storage loss over time, just like we've seen the 100-foot sediment build up under Hoover Dam at Lake Mead. But again, almost undrinkable. Now, of course, then it takes us right down to Hoover. It's further downstream on the Nevada-Arizona border. You know where it's at. Provides water to over 25 million people. While highly diluted by the time it gets here, the cumulative load of organic carbons and wildfire sediment from upper basin fires like this one forces municipal water managers to use more intensive chemical processing to ensure safe drinking water downstream. Anytime that happens, they also probably use more electricity. Now, again, using the Ridgeway Reservoir as an example, the debris isn't just dirt. It's an organic charcoal and ash. It will break down. The bacteria will begin to do that, and this process strips the oxygen straight out of the water. What do we have? Fish kills. Water, fishing. Combined with high water temps, this can cause massive, devastating fish kills within the state park's fisheries. Take the food. This actually happened between Enlil and Inky. Inky resupplied the fish to the rivers, and people survived. So let's look at the big picture. We got all this ash and stuff running down into the rivers. Each reservoir gets a little bit of blockage, a little bit of pollution in it, and on the surface they can, in some areas, apply these floating booms, guys, that collect some of that. You've seen them before on different situations. But because the reservoir levels are already low from the drought, or what I call acidification, there's less clean water inside the reservoirs to dilute the oncoming surge of ash and heavy metals. This causes the concentration of pollutants to skyrocket, forcing water plants to work twice as hard, or water plants as hard, to treat the remaining supply. The double whammy of the storage loss. Drought already reduces the amount of physical water available to local farmers and towns. When a post-fire debris flow dumps tons of mud and rock into the bottom of the reservoir, that's what we're seeing now in the Colorado River Basin feeds. So the drought's already reducing the amount of water available to farmers and towns, and you get a post-fire debris flow, dumps tons of mud and rock into the bottom, guys, of the reservoirs. It permanently shrinks the capacity, again, like the buildup of 100 foot of silt at Lake Mead. And then what do we got? You got a bunch of firefighters fighting a massive, fast-moving blaze, and there's many of them, like the Gold Mountain fire we're looking at now, which has quickly expanded to over 4,200 acres. It requires pulling massive amounts of water immediately, so you're using very variable resources to save what you got. But emergency crews are having to pull water directly from local sources like Lake Lenoir to fight this fire, further draining storage capacity. Water for the future, again, from every direction. Guys, and if you look down in Lake Colorado at Strontia Springs Reservoir, it's a critical choke point shared by Denver and Aurora water. It was absolutely devastated by sediment following the Buffalo Creek and Hayman fires. Even years later, listen, the reservoir remains roughly 10% full of wildfire sediment and ash, stealing millions of gallons of storage capacity and requiring millions of dollars in continuous dredging cost. Mother Nature won't she'll bankrupt you right as she's taking the water from you. Now, two other areas in Colorado, guys, Cheeseman Reservoir, also heavily hit by the Hayman fire. This historic dam experienced massive infills of decomposed granite and charcoal, completely altering the water chemistry and clogging filtration for months. The Gross Reservoir in Colorado, again, following the Cowwood fire, heavy mitigation, including floating debris booms and sediment traps, had to be deployed immediately to prevent ash and floating logs from choking the dam's intake valves. Now you're seeing it on a higher level. Do you see where the crush is going to come from? And again, Mother Nature doesn't do anything halfway. Let's go to the northern Colorado headwaters, the Colorado River main stem, Lake Colorado, again, Shadow Mountain Lake. The historic East Troublesome Fire tore through the region. Heavy rainfall on the burn scar washed unprecedented amounts of organic carbon, ash, and nutrients into these reservoirs. The result was severe water cloudiness and massive harmful algal blooms triggered by the sudden influx of fire-borne nutrients. And it just continues from the very top at the stem of the Colorado River Basin. The Glen Canyon, again, situated downstream of all major western Colorado rivers. Lake Powell is kind of a Meade filter. It was built there kind of to catch sediment. As a matter of fact, it came in later than Meade. That's why Meade is so deep in it at 100 feet. But anyway, situated downstream of all major western Colorado rivers, Powell receives the fine, suspended ash and soot that bypasses smaller upstream dams. It's like a series of filters, right? Because Lake Powell is already hoovering at dangerously low levels due to the drought, this influx of sediment increases concerns over sediment scoring and turbine damage as water levels drop near the dam's river outlet works. Guys, you can't do that. Let me tell you what, they got a series of blades and different contraptions that are part of the turbine system. Some are before the water actually gets to the turbines to control it. And those are the blades that if they had to shut down the dam, those blades close and it stops water from getting down into the actual turbines and destroying them. But if silt gets into the upper blades that can stop the water and control the flow into the turbines, if it warps any one of those blades, they cannot stop it. They cannot mechanically shut down the entire feed because you've got some warped pieces in that particular downflow. So again, it can happen very quickly. And if you go on down back to Hoover, while far removed from the actual flames, Lake Mead accumulates dissolved organic matter from fires across Utah, Nevada, and Colorado still. Water utilities in Vegas, and we've talked about them having to, especially on the third straw and the other feeds out of there, filter with a big company their water. But again, water utilities in Vegas and Arizona are forced to use highly intensive chemical treatment processes to strip out the fire-related carbons to avoid municipal water tasting like ash, driving up the cost, driving up the amount of water, but by the time it's said and done, and decreasing the quality of what you're having to drink. And guys, those events, just for our friends in California, are not isolated to the Colorado River. We've watched Oroville Dam. Remember a few years ago we were covering where they had to let it overflow and basically wash out their whole spillway? But there was a fire there called the North Complex Fire, burned entirely around that reservoir. The winter atmospheric rivers washed entire hillsides into the lake, causing massive logs and woody debris to jam up against the boat ramps and blocking critical infrastructure. So all of the water systems, the Detroit Dam in Oregon, guys, all of them have seen this destruction and the blocking of wildfires. What are we seeing now? Wildfires. Now, let's look at Lake Mead just a moment. We're going to the water databases there. They're really clinging to the 104482. Look at this, 104481. These are by the hour. This is the live, most current elevation right there, 104481. 4 feet, 8.81 above 1040, the lowest point ever, and 9 feet above 1035. But the way they balance this throughout the day, guys, is by what? Decreasing the output. Here's the release, cubic feet per second. They do this, but right now it's becoming a little more desperate. This morning, or at midnight, they were releasing 8,881 feet. They do that at night because to get more power, but right now it's becoming a little more of a balancing act. But now notice to maintain this 1044, Went to 10. It went from 8.8 to 4.5 to 4.4 to 14 to 4 and to 2.23. It's not because it's filling up. That's my point. It's because they're decreasing the output. Why? Because Lake Mead is being limited more and more. But what we see is sometimes an increase in Powell, even though they're saying they're going to save Powell and sacrifice Mead, we do still see those last minute changes. Well, we better get a little more out to Mead than we planned. And that's what we're looking at. Now, to me, this is some sign of what they're dealing with and what we're seeing. Again, 1044.85. They're saying so far today the elevation change has been 0.09 feet. That doesn't sound bad, but it's just part of the day. And you see the decrease in the outflows. That was of this morning. Now, this is going back to yesterday, June the 27th. The inflow was 9,611. Guys, the Bureau of Reclamation stepped in before the end of May and put this down to 7. That was the new rule, right? It didn't last long. They knew it wasn't going to last long. So now that's back up to 9,611. It's still less than the outflow at Mead, even with the increased flow that's draining Powell. You see that? And that change yesterday was, again, they put this in and it changes your drop per day average. And they're starting to remove this, what they call the old chart. And it's going to be a newer, more sanitized version with much less data. But the change, again, dropping from 0.25 to 0.09, this is the drop per day, was because right here. The day before at 0.25, they were discharging 13,845 acres, still at the 94 range of inflow from Powell, 96, 94. But what they did, again, decreased from 13,000 to 10,000. See that? Really a little more. And so it was about a 3,300% decrease in the outflow in cubic feet per second. That salvaged this number from happening again yesterday, this 3,000 cubic feet. And they're trying to balance everything, I know, but I just point out the data. So, guys, that's what we're looking at. We're looking at a complete change of this age in our time. It's amazing. And some changes in these periods are extinction level events. This one may cause a lot of problems along that line, if you understand what I'm saying. But I've also, in these last couple of weeks, focused on the mentality of not fighting the chaos, but adapting to it. If you got to move, you got to move. If you want to stay there, you're going to have to do some massive changes. But you can't let chaos rule your plans. You have to be calm, use logic, look at the data, and say, well, I realize from these videos and others that the desert is not going to be quite so friendly to humans for very much longer. Now, this video, I'm pointing you to moving from the 100th meridian to the 98th and showing you that it's creeping across the U.S. That period of what we're looking at, the Anthropocene, has started. And what is that change? It's the first one ever listed that was from man-made causes. Guys, we're watching it. I want you to watch it. Plan carefully, but remember, Father loves you, we love you, and this is a major heads up. Be safe.
Times are changing, you can feel it in your soul, like the earth spinning out of control. Every window shakes a little, every old lie starts to tight. We're standing on a line, one step, one breath, and nothing stays defined.
The times are changing.
You can feel it now.
The ground keeps turning,
And it won't slow down. Your hands are worn from waiting. Your name is on the wall. The maps don't match the streets now, and the old doors start to fall.
still you keep moving forward
With the dust up,
in your throat.
hold tight. We're standing on a line, one step, one breath, and nothing stays defined.
The times are changing.
The times are changing.
You can feel it now. The ground keeps